Good afternoon, my friends. Am I audible? No, it is.
Yes, sir.
Chalo, let us start. The very basic as well as advanced level, we will continue the journey. But city, as all of you mean the people who have visited Gurugram and visited the yesterday's substation 220 kV, 66 kV and 33 kV. For them it is another very good opportunity to explore. You have seen it, yes, taken the detailed technical spec. I expect all the three voltage levels, 23 kV, 66 kV as well as 220 kV voltage level, it is with you. Whatever we assume today, based on yesterday's the site visit or the substation visit, that is Haryana Vidyut Prasar Nigam Limited, but the basic remains same. The very purpose of current transformers, the full form of CT is current transformers. Mainly, it is designed and defined for measurement or measuring the current, mainly, primarily, and additionally, it is protection. So whatever the voltage level, in fact, any voltage level, if it is at the 4 to 20 milliamps also, which is under control and instrumentation's role under power sectors. So milli and micro, that is also to be measured through the CT, like smart meter also. We'll discuss from the smart meter how the interposed CT is important for a electrical engineer and circuitry. So it is not that circuit which has visited yesterday till 220 or 400 and even more voltage level, but at the low voltage level, it is also parallelly and equally responsible for us to know how. So this is very basic, key current transformers, and as a whole, we are just saying an introductions of the programs before going towards the next slide and next chapter of discussions. These two will be the chapter of discussion today. Next, we could surely manage. So all these things are part of the protection. That is the separate color altogether with a hand. But fast is CTPT and fast and foremost, very, very essential to item or equipment, sensing, detecting equipment, sanitary watchdogs, protective relays, locating and initializing the removal of fault, locating and initiating the removal of fault. But removal से भी पहला है कि how the chapter relay and for protections, there are alarms before the trip. So fault location with a certain indications and with a flag. So there are different kind of relays we'll discuss when, if I or somebody else will surely suggest them, because we are just discussing with the best persons. At present, I am not the best, though earlier I would have been into this, so I don't understand the best. We are bringing people only to showcase their expertise. It is power grid, if it is NTPC, if it is the manufacturer like Siemens as well as ABB, Hitachi. Today also we discussed. And with MNC, I mean the manufacturer mostly they are from outside the country. That's what it is, truly multinational companies. It is not the customer. Customer are the end users or end clients who knows relays, who are used to the relays, but at the same time they have very least experience on the manufacturing segments. is the gray area from customers. Manufacturing end, they never seen. Sometimes inspections, if, then else. So we'll discuss. Circuit breaker is a very, very important and very effective actual removal of fault from power systems. This is the introductory, it is not the actual definitions. So you know the difference between a circuit breaker and isolators, what we have seen yesterday. So these are the preliminary, right? I hope other than online people or online friends, uh, mostly other people or 50% attendance was there from physical, right, at present yesterday, including Sumit. So I hope and I expect people already have some idea and people are already studied yesterday. Because we have given you the relaxations after lunch. Means it is not that relaxations. Those who are in CBIP also, they have just directly connected with the labs or the system to start their projects, whether it is Uday or uh, Indranil. Okay, so they have started. I expect whatever your problem, whatever your pain, don't think it is pain for you. So please be there in the CBIP premises till 5 or 5:30. After site visit, try to understand what exactly class is there or not class, that we will discuss next. But we have to jot down the complete picture. There are n number of areas where we have to understand the very preliminary introductory sessions. The question, yesterday we are discussing how the current transformers and the power transformers, conventional transformers and current transformers, what are all differences? These are the very basic questions and everybody has to understand. This is very basic and very important. Bhaiya, kya bata do yaar? List out 3 or 4 areas how we could differentiate and compare with the power transformers and current transformers. First, equivalent circuitry or phasor diagram. This thing we have learned from the college days, if I'm not wrong. We have a specific chapter in the class, 7th semester of BTech, instrumentation and measurement. Still I recall I have learned very clearly the phasor diagram, right? This is theory and equivalent. Both I expect everybody are already clear and on track. But I don't know how this is not been there. So my duty is to just share what we have learned and what we have not learned till date. So we have to learn those things. Why CT cannot be open circuited while primary is energized? Very important questions. CT errors, CT ratio, accuracy limit factor or ALF, voltage developed across CT secondary, number of cores, list of parameters of CT specification and other applications. So these are the prospective areas we have to learn, we have to understand and apply. My presence under CBIP is to just give you the mileage more into applications, not into theory. As I told in the beginning, you should start your journey from site, from manufacturing side, substation side towards the theory. You have to match those theory from the ground real experience. How the city looks like and how as a customer or an end user I could use it in better format. This is the very basic 3 difference we have just considered here. Driver, the driver is here voltage, here the driver is current. Here secondary load impedance determines the secondary current, and at the same time under CT, primary current is the driving force. Corresponding circuitry or the flow diagram, how the power is flowing here within a conventional or power transformers. So this is primary current and this is secondary current. At the same time, these are the conventional picture or the legend to show under any drawing. CT का presentation ऐसे ही होगा, ट्रांसफॉर्मर का presentation ऐसे होना चाहिए. इसमें भी लॉजिक है. Can anybody put any light, any comment, any particular confidence to me? Why this? Any logic, any idea from your mind? What may be the basic reason to put this legend? And before that, I just want to learn, anybody has visited any plant? Anybody have visited the open segment of power transformers or the current transformers? Constructional features. So constructional features means during manufacturing, how the things are preparing all the component part, then assembly, then complete product, then testing, prototypes, then release. That are the phase of a product. So any product, anybody have visited any or any idea how the current transformers constructional features? No, right? We will show you the constructional photographs also, how the primary currents. Once you see the constructions diagram, construction photography, I hope power transformers everybody has studied. Why these two goal? Very easy. This is the. Yes. So anybody, Aman, Sumit, or others, I don't know how many. Indranil. क्या है इसका पीछे? We'll discuss next. Let me finish fast because today time is very short for me. Let me finish, and even if not finished today, I will extend today's time, maybe 6:30. Because CT and PT I have to finish. 2:30 to 3 is my meeting, and then again I will come back. In between that, we will take a break. So that's what I have not given the break, long break for lunch. So please make sure your availability after 33 again. So 2:30 till I will continue, then again 3 or 3:10 I will come back for attending the meeting. At the same time, people should understand, yes, equivalent circuit and phasor diagram. This is very easy. I hope it is not new for us. Very easy. How the primary current is coming and made up of two components. One is your magnetizing current, another is your what current? Two components? Magnetizing current. Correct. So excitation current, exciting current, and other is your exciting current, or another is secondary current. These are the two components. Let's see the circuitry. Very easy, right? So how this is a current transformers. These are the two parts, right? These are the two parts. So this is just distributing here. Primary connected to current source, and this is IE, exciting current, right? Primary current जा रहा है यहाँ से जाके इधर हो गया. Exciting current are dividing into two parts. First is magnetizing, and the IC is core loss current, right? Then how the secondary current is here, right? So primary connected to current source, and how the distributions and conversions to the secondary with a burden, or rather a meter, relay, whatever. This is secondary burden. Please be ready to listen and care how the secondaries. Whenever we discuss with a meter, these are the component, which component are treated as burden. Whenever we discuss next the technical specification, how the burden, VA, right? We'll discuss. whether it is CT or CVT. We expect everybody knows into this. We are not giving much time here. If people are not understanding, again we'll go. My target is to just application what we visited yesterday. We'll again come back. This is very easy. Everybody knows. All theory academic people knows, but we are not at present academically. Academic we assume and pre-assume people already studied. Now this is the thing. Based on phasor, how this is related with the applications. Yesterday we are seeing is some kind of current. Primary current are coming and secondary are connected with the marshalling box. And that marshalling box are coming to the control and relay panel. All the interface were or varying. So please be careful whenever yesterday we have visited the CT through conductor it is coming and that conductor is coming through this much of current. It depends on the voltage level. 2000 or 1000 or 600 that depends on the voltage level. At high voltage or extra high voltage. If it is high voltage, what will be the probable or expected current? Anyone please? 66 kV is the line. Yesterday we have seen these are very basic calculations because whenever we discuss, we have to take it very carefully and seriously. If it is 66 kV, size, just a minute. It is very simple. 2000 की जगह I have asked कि क्या रहेगा? Anybody please? 66 kV मोटामोटी क्या रहेगा current value?
Sir, 874 amps.
Yeah, correct.
Upper 100 MVA transformer.
Source, signal here?
100 MVA transformer.
नहीं 100 मत लो यार 66 kV में 100 कैसे? 66 by 11 में power transformer वाला 20 25 MVA आता है. Right? So, 66 kV there is defined relationship and concept I will convey. ये housing model 5 bay. आपको 5 bay का exercise किया right? 2 number sub-transmission line of 66 kV, 2 number trafo bay 66 by 11 and with a 20 to 25 MVA का रहेगा rating. This is very basic calculations which we have not learned during the study. So one is academic, बार बार हमारे वो हो रहा है academic के बाद experience हो गया कि 66 kV में अगर मेरा 20 या 25 या whatever transformer ratings आप पूरा करके क्या होता है line का क्या होना चाहिए tentative indicative. I am not yet to give you the final or firm data. 600, 300, 900 जो भी है and मैं वो भी बताऊंगा कि भैया कहाँ से कहाँ तक जाएगा. Is it visible to all of you? This 2000/1, right? So now what we have not seen from the outside, किसी का zoom नहीं आ रहा था, वो नहीं आ रहा था. Now this is the inside story देखना है. पहाड़ सामने वो देख लिया. It is a visibility from outside. Whenever we give the destination next to this slide, today I will continue the manufacture like ABB का city पढ़ा है मेरे पास. वो आपको दिखाएंगे कैसे view